Hello engineers, welcome back. In this video, let's discuss network protocols, which is our next topic in system design. I hope you're ready. Let's get started. So we'll start with the basics. What are network protocols? So by definition, network protocols are rules for data exchange over a network, right? So there is data being exchanged over a network and we need some rules to make this data exchange happen. So those are network protocols. So why do protocols matter in distributed systems? Because with protocols we get some kind of organization. That is one thing, because a network of computers is a huge network. There are thousands of computers and we need some way to keep them all organized. We need rules like traffic rules, right? So that's what network protocols give us. So they give us some organization. And the second one is we get some standardization, standards. So because of these protocols, we can be sure that one type of data will go in the right way, right format, to the right destination using these protocols. So there is some standardization in place. So the kind of data we need, the kind of protocol it needs to use to travel from one place to other, all of these come under the concept of network protocols. And these are very helpful when enforcing standards. And the third one is reliability. So because of these standards and organization that we get with network protocols, we can be reliable that the data I am transmitting will eventually reach you through some route, through some protocol, but eventually it will reach you. So it will give us some kind of a reliability, like a tracker system, right? So these are some of the benefits of using network protocols, or rather these are why network protocols matter in distributed systems, right? So if you want to think about a real world analogy, think of it like a postal service. So I want to send a parcel from place A to place B. I go to a post office, I drop my parcel at the post office, and the post office takes care of routing this package through its network of distributors, and then finally it will reach my destination safe and sound, right? So that's how data also works when it comes to traveling through a network of computers, right? So let's try to understand this in a deeper context. So now let's try to understand networking models. So there are two main models for us to understand. One is the OSI model, also called as Open Systems Interconnection, and the second one is TCP/IP model, right? So the OSI model has 7 layers, TCP/IP has 4 layers. So this is more of a theoretical, conceptual idea about how data should travel over a network, and this is what real implementation looks like, right? So let's have a look about how these layers work. Let me try to close this. Right. So let's try to understand these models. So first is the OSI model. As you can see in this picture, we have 7 layers: application layer, presentation, session, transport, network, data link, and physical. And if you look at it in comparison with TCP/IP model, we have 4 layers: application, transport, internet, and network access layer. So basically, application layer is a combination of these 3: application, presentation, and session layer of the OSI model. Similarly, network access layer is a combination of these two, right? So that's all we need to know about these two models. Let's try to understand the layers now. Let's take an example. Let's say I want to send a message, or rather you want to send a message to me, and maybe you've added some data or you're sending me a photo, right? So this is what happens in the first layer, the application layer. This is what user wants to send, right? This is the actual data part. In the presentation layer, this is how the data is presented. Maybe you want to wrap it as a gift, or maybe you want to do some translation, right? So this is where the data is transformed, or data is compressed, or data is encrypted, right? So there are different ways in which the data can be presented. So this is what the presentation layer takes care of. And the third one is the session layer. So this is where the tracking happens. So you call your friend to say, I am sending you something. So we are initiating a communication that there is something to be coming your way. So in this layer, we will take care of start, ongoing interaction, and also the end of the communication, right? So this is where the tracking part is happening, right? And then we have the transport layer. This is the how. This is where we choose the delivery method. Do you want to use a reliable courier, or you want to use express mail? Right? So in our context, there are two approaches available, TCP or UDP. So if we take TCP as our transport mechanism, it is slow, but it is guaranteed because it has some tracking mechanisms in place. And if we choose UDP, it is faster but unreliable. So we will take a look at all these two protocols in detail. Let's continue with our layers. So the fifth layer is network layer. So this is where the route is planned. So like I mentioned, a network is a combination of thousands of computers. Not just computers, there are routers, there are switches, there are data centers, there are many things, right? So how does my packet, or how does the message that you're trying to send to me travel across this network of computers and reach me? So that plan is laid out in the network layer, right? So courier checks the destination address, finds the best route. So this is where IP addressing and routing is happening. And the sixth one is data link layer, right? Now package has almost reached me. So this is where the local delivery rules happen. So the delivery guy checks building access, security gate, and flag number. So this is like the packet has reached my ISP, but it has not exactly identified this computer, right? So maybe there are 10 or 20 different devices in my home. It needs to identify this computer. So this is where the nearest router switch or the MAC address or the local communication rules happen, right? After identifying all this is where the physical layer happens, where we actually deliver the package. The raw bits are coming into my computer via Ethernet or Wi-Fi. So this is like walking to the door and actually giving out the package, right? So finally the message that you sent me is received here. Okay, so this is how the OSI model, or this is how any data is traveled across the network, right? So from application developer point of view or from system design point of view, we have control over these two layers. We can choose what data to be sent, how it should be transcribed, or how it should be formatted, encoded, or encrypted, or compressed, all that. And we can also choose how it's supposed to be sent, whether via TCP or UDP, right? So this layer is mostly out of our control. So the routing and everything is taken care by DNS resolvers and the whole network of things, right? So we will focus on these two. Let's go into detail and identify what are the things that we need to learn in application layer and transport layer. Okay. So let's start with transport layer protocols. So this is where we choose the courier about how our data should be traveling through the network of computers. So we have three options. First is TCP, which is transmission control protocol. Second is UDP, which is user datagram protocol. And the third one is the new one, which is QUIC, also known as QUIC UDP internet connections, which is basically a hybrid of these two, right? So let's try to understand these with some examples. So let's say we have Tinku. Tinku is our TCP courier, right? Tinku TCP. So Tinku is a reliable courier. So what Tinku does is, Tinku goes from home to home and then delivers packages, okay? And while delivering, he always takes care of verifying that the package is actually delivered. He takes signatures from the recipient and all that, and he also goes in a particular sequence, right? So this is TCP for us. So meet Tinku, your best courier. He's extremely careful, always gets a signature on delivery, tracks every package, and if something goes missing, he resends it. This is also another piece. There is retry involved, and never delivers out of order. So he also keeps a track of the sequence in which packets should be delivered, right? So the pros and cons are like this. So reliable order delivery, but the cons are it is slow startup. So there's a handshake process involved, and that takes a little bit of time. And then it is slower in bad networks because it is waiting for acknowledgements and retries, and it cannot multitask well because head of line blocking. So head of line blocking is nothing but when one package is slow, naturally the rest of them are queued up because we need to ensure the proper order in the delivery. Yes, so this is one of the cons of TCP. Now let's meet UDP. So let's take an example of another guy called Umesh who is on a bike, right? So he's holding a bag of packages and he's the unreliable express mail, right? So this is what Umesh does. So he goes from home to home on the road and he just takes a package, throws it to the house and moves on to the next house, right? He's not waiting for any signatures or any tracking or any resending. And let's say there are some speed breakers, then the bike is jumping over them, maybe some packages fall off. He's not really worried about them. He just continues to go in the direction that is intended to go, and he just drops packages on the way, right? So Umesh is our fastest bike delivery guy. He does not wait for signatures. He just throws the package and drives away, right? The pros are it's extremely fast, right? And there is minimal overhead because there are no handshakes involved. And the cons are there is no guarantee of delivery, packets may drop along the way, and there is no ordering guarantee, packets may come in any order, and there is no retry, right? He just goes away, right? This is especially useful when we are doing streaming stuff, like when you're watching a match or when you're on a Zoom meeting or anything. So it does not matter whether the packages come in the exact same order. Also, it does not matter whether if some packages get dropped along the way, right? The streaming must continue. So there is no head of line blocking, which is blocking the rest of the queue, right? So that's how UDP works. And the third one is a hybrid model, which is QUIC. Let's say Quinn is our drone delivery guy, right? So this is a hybrid of TCP and UDP. So Quinn now has a drone. So he's just controlling the drone using some remote, and the drones are delivering the packages. So while the drones are delivering, they're making sure to take the signatures and verifying the sequence and everything, but they're also fast because they're just flying in the air instead of going by the route where there could be junctions like this, traffic cops and all that, right? So let's see. So Quinn is our drone delivery guy. Quinn flies fast like Umesh because it uses UDP internally, and it uses encrypted GPS tracking to make sure that the packages go in a particular order, and we can also do retries, right? So gets delivery confirmations, can also carry multiple packages in parallel, and if one fails, it does not block the others, learns routes, remembers past addresses, right? So these are some of the features of the QUIC, and these are some pros and cons. So it is secure because it has TLS built in. TLS is the encryption, and it is fast because there are no handshakes involved like TCP, handles packet losses smartly, and it also supports multiplexing to ensure that multiple packages can be delivered. And cons are it is still a newer technology, not as widely supported or compatible, and it just falls back to TCP in case of any failures or in case of any retries required. Okay, so this is how QUIC works. So this is all about transport layer protocols. Now let's look at application layer protocols. So there are several protocols involved here: HTTP1, HTTP2, HTTP3, HTTPS, and also Websockets. So let's understand all these again with some analogies and examples. So let's say we are in a restaurant now and there is a hungry customer, right? And the customer is hungry, but the waiter is only able to deliver one dish at a time. So this is HTTP 1.1 for us, the waiter who does one thing at a time, right? So let's say you walk in and order a 10-course meal. Waiter can only bring one dish at a time from the kitchen, right? So this is very slow, as you can imagine, especially with many small requests. Like if you want a web page to be rendered, we need many of these assets, right? HTML, images, CSS, JavaScript, and so on. Imagine if they are coming one at a time, the page load is extremely slow, right? So this is how HTTP1 used to work. There is no parallelism involved, and it also causes head of line blocking. It was mainly used in early websites. Modern sites need many assets in parallel, right? So this is the analogy. So the waiter is able to just give one dish at a time, and the customer is unhappy and still hungry, right? Now let's upgrade our technology to HTTP2, and let's see. So now the waiter is having a smarter delivery system. It means that the waiter, instead of carrying one dish at a time, is carrying some kind of a tray which is able to carry multiple dishes at a time. So the customer is slightly happier than before because there is less time to eat, basically, right? So waiter can carry multiple dishes at once, which is also called as multiplexing, right? Still uses the same delivery protocol, which is TCP, but works more efficiently. And it also uses binary format for orders, which is faster and smaller in size, right? And it also able to prioritize important dishes first. So that is also one other feature of HTTP2, much faster. And the con is if one dish is dropped, the whole order waits. So this is again a protocol limitation of TCP, like we discussed before, right? So that is HTTP2 for us. Now let's upgrade even higher to HTTP3. Now let's say our waiter guy is having a drone delivery system in place, right? So instead of traveling through the network of the restaurant tables, now the waiter can just fly the dishes to the customer using some drone technology, let's say, right? And it is extremely fast. So again, this drone is able to carry multiple dishes, similar to HTTP2, right? So it's similar to HTTP2 in terms of multiplexing and everything, and it's faster because it avoids line traffic. Okay, so it still supports multiplexing, but no delays. Even if one dish drops, it has built-in encryption. You don't have to request a secure tunnel, and it is fast and secure. Best for unstable mobile or public Wi-Fi networks, right? So this uses QUIC, like you can imagine, and we have discussed the pros and cons of QUIC just now, right? So this is how HTTP3 works, right? So now customer is even more happier because not only are the dishes getting delivered multiple dishes at once, but they're also extremely fast, right? Now let's move on. Now let's talk about WebSockets. So WebSockets is slightly different. So the protocols that we discussed so far are one-way communication. There is a request being placed and the order is delivered, right? So it is one-way traffic. But here it is a bidirectional communication, also called as duplex communication. So this is how WebSockets work. It is an open line to the chef. So there is no need of a waiter anymore who is delivering stuff. So we have a direct communication with the kitchen or directly to the chef. So because we have this, we can make some customizations. Maybe we want to have a vegan sushi or anything, right? And the chef is directly talking to us and there are no middlemen, and we can talk as many times as we want. So the communication is established once and we are able to do multiple communications between that, right? So this is how bidirectional communication works. So you want to talk to the chef directly in real time, right? So you get a private line to the kitchen. So this is where the session that has been established, and it's a secure session. Only both of you know what is happening inside, and you and the chef can talk anytime, not just in request response cycles, right? Unlike HTTP, it is bidirectional and stateful. Starts as HTTP, then upgrades to a WebSocket tunnel, right? So it's initiated as a HTTP connection request and then upgraded to a WebSocket tunnel request. So that's how WebSockets work. Now let's talk about HTTPS. So for all those previous protocols, we can apply the security layer, which is nothing but our TLS, right? So with TLS, everything is encrypted. The whole communication is encrypted. So let's take this analogy again. So let's say we are doing our drone delivery using HTTP3, which is using QUIC. Now, instead of directly showing the dishes, now I'm not showing the dishes. They are encrypted now. Now it's a top secret. So even this guy does not know what is being delivered, right? So previously we were able to see the dishes, right? So there is some kind of a cake and there is some kind of a rice bowl or something. But here we don't know what is being delivered, right? So only the person who made it knows it, only the person who eats it knows it, but nobody in between can know it. So that's how generally encryption and HTTPS works, right? So every order is encrypted, no eavesdropping. Even the waiter doesn't know what's being served, right? Uses TLS under the hood, ensures privacy, integrity, and trust. Mandatory for modern apps, right? So this is how HTTPS works. So this is all we need to know about application layer protocols. Now let's see the final piece, choosing the right protocol. So how do we choose it? So like I said in multiple videos, like every system design decision is a trade-off. There is no one answer for all applications. We need to choose based on the requirement, based on the available resources and things like that. So one of the trade-offs to consider is latency versus reliability. Is your reliability more important to you or latency is more important? So if I'm watching an IPL match, for me latency is more important than reliability. I'm okay to drop a few packets, but I want to have live streaming continuously flowing through, right? So that's when I will choose UDP. And if I want reliability, I want every packet to be delivered in a particular sequence in the proper order. Let's say emails, right? So that's when I'll use TCP and so on. So, and there is also a trade-off between stateless and stateful. So this is where we can choose between HTTP or WebSockets, right? All HTTP requests are basically stateless. One request is unaware of some other request. But in WebSockets, we can have a stateful communication, right? Because it is a bidirectional communication and the session is established up ahead, right? So these are some of the things to think about when we are discussing network protocols in system design, right? That's all I had for this video, guys. In the next video, like always, we'll try to do a demo about all these concepts. So stay tuned for that. Please leave a like if you found this video helpful. Do stay subscribed and subscribe if you haven't done already so that you don't miss out on the next videos. Thank you so much for watching, guys. I will see you in the next one. Cheers.